বলছি ইন্ডিয়ান সেন্টার ফর স্পেশালিস্টটা খুলুন, ইন্ডিয়ান সেন্টার ফর ইন্ডিয়ান সেন্টার ফর সেন্টার ফর বা আইসিসি কলকাতা লিখুন, আইসিসি কলকাতা লিখুন, লিখে সার্চ করুন। হ্যাঁ হ্যাঁ ওইটাই লিখুন। এবার এখান থেকে শেয়ার করবে বা যদি কাউকে দিচ্ছে, হ্যাঁ ওটা শেয়ার বাটন আছে দেখুন নিচে, ওটা কেটে দিন আগে বন্ধুটা। হ্যাঁ নিচে দেখুন শেয়ার আছে, শেয়ার বাটন আছে, উল্টোনো একটা আরো ওটা গোল মতো আছে। হ্যাঁ 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 লাইভে চলে গেছে।
Hello. So the program will start right now after they are getting the lunch. So whoever is having any questions, there should be any questions from you. But we have limited time after our show, so you should write down the questions. They are giving some slip, your name, your designation, and something, and your questions. We will collect them and we will solve from them and we will ask. Okay. You free to write those questions.
Please keep silent. You know, we want to, after a long wait, we have been able to have Captain Shukla among us. In fact, we cannot even believe ourselves that he is physically here in this building. Very much difficult. Those of you who know ISRO, a big, extremely strong bureaucracy, and we wanted him to inaugurate the pavilion named after him, but they did not allow, and then they did not allow one-to-one interaction also. They have reasons, so I am not complaining. But I am very happy that he has agreed, that he has already given some answers. Now we will be basically going with the program. We are already about half an hour late. Sorry for that. Partially there was landing problem, there was already the indigo head problem. But we are trying to be within the time, and we want to complete our program by 5 p.m. So the program will be like this. First, our group captain, Mission Kundu, governing body member, will welcome group captain Subhanshu Shukla, our first Indian astronaut who visited International Space Station. As you know that this space station was made primarily by USA, USSR, and of course European Union, Capt, ISA, European Space Agency, and DCA. In fact, some of the first ones, like Bezda, 1988, started. They started aeronautics, and there was some delay of this going up. So those of you who are in India, we know that every day we have been updating why there was a leak and where there was a leak and how many grams of air is getting out of the system, and that has to be per day less than 200 grams. So all kinds of things we have discussed. Many of you are more, you know more than many of the scientists. Now we are extremely happy that after all that he landed, and after all the formalities, after everything is over, and he is after the normal, he has a huge responsibility to take our space program, human space program, forward. As you know that when our Rakesh Sharma went 1984, India was not quite ready. Even the ESLV rocket was not launched. ESLV rocket was launched in 1993. Rakesh Sharma went in 84. So whatever he learned and came back, India could not make use of it immediately. We were not well prepared. That's my understanding. But right now, today's India is totally different. ESLV, GSLV, and Mark, we see that all these LBMs going on after another. And just a month ago, about 4 tons items have been sent up. So India is catching up, and so this time we have enormous interest in everybody. People visit museum, they always say, my son wants to become an astronaut. But I don't want to dampen them. I say, look, there are 12 billion people on Earth, only 12 people will walk on the moon. So there is 1 out of billion chance that your son will be walking on the moon or Mars. So don't get disheartened if your son cannot walk, but probability will go up a little day by day. Today we don't want to prolong anything. I will first go straight to Group Captain our Kundu, welcome him. After that I will say something about how much can we possibly explore in the universe, and then the main part comes. Captain Shukla himself is going to TikTok as much as he wants, and then there will be a panel discussion. Why do we go to space? And then, of course, students will have asked questions. So all of you have been given, many of you have been given a questionnaire, name, school number. None of you can ask directly. We will take the questionnaire from you, and then we will try to sort them in a way that only the most intelligent one questions will be given to you. You cannot ask the question why this guy is that there and so on. Easy questions, no, you have heard it enough. Try to ask very intelligent questions. Then only we will pass it on to you. Okay? So this will be the program. Up to 5 o'clock, the program will go on. And maybe 4:30, 4:45 or so, the program will continue. So I request Group Captain to please welcome. Yeah, please, first of all, you come. I'm sorry. Please.
Yes, switch off that and hang your light.
Round of applause.
We are not professional in event management. So, sorry that we. So, he is our chief staff individual.
Good afternoon. So the time has come for which we all were waiting. The vast sky and unlimited space always fascinated human imagination. Shelley, the English romantic poet, wrote his famous ode to a skylark, and I quote a few lines. Higher still and higher from the earth thou springest like a cloud of fire. In the golden lightning of the sunken sun, thou dost float and run like an unbodied joy whose race is just begun. Ladies and gentlemen, girls and boys, today we have gathered here to hear about another race, Indian human space flight program, right from the horse's mouth. Yes, ladies and gentlemen, it is indeed a moment of pride and glory, not only for the Indian Center for Space Physics, but for the academic and scientific community of Kolkata and West Bengal, that we have among us the first Indian astronaut to visit the International Space Station, Group Captain Subhanshu Shukla. On behalf of all of you, it is my privilege to extend a hearty welcome to him. As a brother officer of Indian Air Force, my heart swells with pride at his unique achievement. Sir, we truly believe that your presence among us will ignite the younger minds of the students and electrify the interest of the scientific community and arouse interest among common public in matters related to space science. Adventurous by nature, you joined the National Defense Academy after leaving school. Thereafter, you were commissioned in Indian Air Force in 2006. Besides doing thousands of hours of operational flying, as a qualified test pilot, You have a varied experience of flying almost all types of aircraft in the arsenal of Indian Air Force, including MiG-29 and Sukhoi 30 Mark 1. This day will be marked as a red letter day in the history of the Institute. In the last 26 years of its existence, it has run successful independent space program and carried out research activities in different branches of astronomy, astrophysics, and space science. The scientists who got their PhD from here are now successfully working in the premier organizations like TIFR, IISC, ISRO, etc. The large audience here and in other halls are eagerly waiting to hear from you. Before closing, I must welcome all of you audience who have come from far and near. The date of the movement was finalized at the 11th hour, so many of the dignitaries could not appear in person. I will read the messages sent by them. This one is from the Honorable Governor C.V. Anand Ghosh. The Honorable Governor of West Bengal conveys warm greetings to the Indian Center for Space Physics and to all distinguished guests, students, educators, and participants attending this special program. For over 26 years, ICSP has contributed significantly to the advancement of astronomy, astrophysics, and space science education. As the first space startup with an independent space program, the Institute has carved a unique position in India's scientific landscape by nurturing young minds and cultivating a spirit of inquiry, innovation, and research. The presence of Group Captain Subhanshu Shukla, the first Indian astronaut to visit the International Space Station, adds historical significance to this occasion. His journey stands as an inspiration to countless learners across the nation, reminding us that with knowledge, dedication, and courage, even the vastness of space becomes a reachable frontier. Such programs bridge the gap between classroom learning and real-world scientific endeavor. They ignite curiosity, encourage young students to dream beyond boundaries, and reaffirm India's growing global presence in space exploration. The Honorable Governor appreciates the Indian Center for Space Physics for its pioneering effort, its world-class Museum of Astronomy and Space Science, and its commitment to bringing space research closer to the people, especially the youth. The Honorable Governor extends his best wishes for the success of the event and for ICSP's continued contribution to the nation's scientific progress. And this one is from the Honorable Chief Minister, Mamata Banerjee. The message reads 8th December 2025. I am happy to know that Subhanshu Shukla Pavilion will be inaugurated at the premises of the Indian Center for Space Physics in the presence of the renowned Indian astronaut Group Captain Subhanshu Shukla on 10th December 2025. On this special occasion, I convey my heartiest greetings and best wishes to the officials, faculty members, scientists, and students of the Institute, and wish the event all success. Signed, Mamata Banerjee. I request the volunteers, please show the children the other halls where you can sit and have it extended. And now, on behalf of the institute, okay, we present it to Group Captain Subhanshu Shukla. And we have got a bag of memorabilia of the institute, and I request the director, Dr. Shamil Chakraborty, to please hand over the memorabilia to Subhanshu.
Somebody coming from race. I want to show one few things. That this one is actually this pavilion that we just inaugurated. No. I expect. This is one. This is the picture of the pavilion. And we have very cleverly had a picture of him in our copy, so that we can hang it in our own paper. This is this pavilion photograph. And a few things, one more thing, Rakesh Sharma ji came, as you know. So there was a cup we made in memory of Rakesh Sharma ji on that day. So this is the cup that we contains the Rakesh Sharma ji. So this is the one that of course we made, and we are very happy that we give it to him. And of course I am not going to show other things.
Subhanshu. In your journey of last 25 years, you have
There is
carried
one more thing. A t-shirt. I done the Martian moon at Indian Center for Space. So that's a t-shirt. It says I touched Martian rocks and lunar rock at Indian Center for Space. This picture.
because he's our protection.
Okay, so what you have touched here and so. And there is lot of stuff. It is the first day cover on Rakesh Sharma's visit and the first day cover on public for 25 years, whatever we achieved. And we have produced 54 PhD students. It's a good number because they have also produced some more. So India has now almost 300 PhDs which have come from our institute. Okay. It's a scientific thing. Almost every institute has our students. So now let us please have seats now. Oh, please come.
On behalf of the governing body, a specimen of Bengali craftsmanship and huge piece of historical culture being presented Gautam Banerjee and Dr. Sonali Chakraborty.
This is a Jolghora Sandesh, almost 1.5 kilogram. I think that this is diabetes. Next time he comes, sugar level will try to check.
I assure him that no one will be spirit of based on his dress because zero gravity.
Okay, I am not sure. No, I think that. Okay, so let us start the science part. The both put the Shukla like turn on the lights, please. Okay, so we want to start. We will see originally it was 30 minutes, but I will be seeing 10, 15. We are really running here, and we want to hear Capt. So I want to start with a small space exploration program that we do here. We have a balloon program at say about 1 kilometers from here. From where we launch balloons and we launch pillows. Okay. So these are the kind of balloons we are send. These are about 100 feet big, and you can see that the rockets go to space. And you have seen the pictures of Captain Shukla's beautiful description of how the Earth looks like and the sky looks like and the sounds look like. So we don't go to space. We don't know where the space starts. Officially, it starts from 100 kilometers. It's called government line. But by balloon, you can go maximum 43, 45 kilometers. Okay. So this balloon that is going up, just watch for the following. As the balloon is going up, the size of the balloon is going to become bigger, and the sky is getting dark. It is getting black. Okay. In other words, we have entered into space. There is no scattering, and from there we start taking data. After taking, you can see the some round shape in the earth. Okay, you can see the entire Himalaya mountain range from here also, and then the balloon actually bursts. This is about 42.5 kilometers, and then it comes down. So this is our four-man's way of doing space research. Now, the reason why I want to encourage this is because this gives us as much thrill as when somebody comes back from ISS or from moon or from other place. Okay, because we thought it is lost forever and God knows what they are going to do. You know how soon the Williams got stranded and we are sorry about it. So when you see your payload is coming back and landing, you feel okay, your item is coming back and now you want to do research on the data that it has come. Okay. So you go to the next one. So this is landing and we have sent 114 times. We are actually world expert on this subject. And two students have received PhD from Calcutta University from our data alone. Okay, it is just like satellite. We send the same instrument, but it's an luxury. Less than $1,000 per on board. PPT file. Okay. This is small link. I don't know why this is not working. You did not put any dongle there. So now the fundamental question I want to ask you today is that what is space and how much of the space can we possibly explore? Okay. You have to understand that the balloon will go up to 43 kilometers from radio propagation up to 120 kilometers, and satellites near Earth satellites are 250 kilometers and above. But these are in kilometers. Okay. But the universe is pretty big. It is 14 billion years old and it is as big as 10 to the power 23 kilometers. And so, when we say astronaut Captain Shukla, who Captain Shukla, remember the word astronaut. Okay? Astronomy, astronaut, astrology, astrophysics, all came from the word astro, star. An astronaut means he is happily going from stars to stars. Does it happen? The answer is no. He went up to about 450 kilometers. But still, that is huge for a human. That's huge. That's a fine frontier. That's there the fighters. anything could have happened, the life would have been in deep trouble. It didn't. You have seen what Sunita Williams was worried about. So out of this almost virtually infinite universe, we merely scratch the surface. We did not go to space very much. 400, 500 kilometers, okay. Those who went to moon, 400,000 kilometers. So big deal. Elon Musk wants to go to Mars, couple of hours light crossing time. Moon is only 1 second light crossing time. Moon's velocity is 300,000 kilometers per second. And moon is typically between 356 to 380,000 kilometers to 400 some thousand kilometers. So around that number, 1.2 seconds only takes light to go there. From 1.2 seconds, we have to go to 14 billion years. That is the big. Can we go there? The answer is no. Can we go to this? Okay. So now the space exploration, there are many types of exploration. One is that you go to space and look towards Earth. India has been doing for a long time, and that is the best thing. That is why India is mature in that topic. We have to look for the resources, also the telemedicine, and all kinds of transponders. India was trying to do things for the good of the people. It's a huge country, huge inertia, 140 crore people, So India is slow, but steady. It is irreversibly, it is going on. Nothing happened so far which is as catastrophic as Apollo 1 or Challenger or Columbia disaster. No, we hope nothing will happen like that. So India is very cautious, taking small step at a time, so that the progress is irreversible. So that nobody, either political will or something, say, no, we must stop this program. Okay, because people are dying. So these kind of things could disrupt the program. So that is why India is doing it at its own pace. We should not compare with India's pace with the pace of China or other countries. Okay, that is point number one. Second thing is that you send something there because you want to study stars and galaxies and the formation of the universe. Like what happened in James Webb Telescope or the Hubble Space Telescope. Okay. So you are not going anywhere. You are just putting your orbit at some place, your satellite, and starting the universe. That is what we do. Look towards the Earth or look away from the Earth. And the third part is, of course, to get out of this place. Okay. Now, like Voyager is get out of this place, and from 1977, it has gone only one light day distance. It has to go almost 14 billion years. That is the size of the universe. Only it has done one light day. Last 40 years. Okay. So this is the problem. Our speed is so small that even the nearest star, Proxima Centauri, it will take about 70,000 years to go. Okay. So can we? Going to moon is fine. We are going to go, as Capt. Shukla will tell you when and how we are preparing for it. We can go to Mars also eventually, probably within 100 years. But space is vast. There is so much things to learn. The question that philosophical question, that your brain, is your brain capable of understanding the entire universe? If I give you everything about the universe, will you be able to learn that? Number one question. This is for the young student. Second question is, how much of the universe was really needed to create us? Did I need the whole universe to make ourselves, or only the solar system, or only the region around the Earth? Okay, this is a question. Inverse question is also true. How far can we go? Okay, velocity of light is fixed, 3 into 10 to the power 10 centimeter per second. So no matter what you try, there is a limit, and there is, so that is where the comes in. So this is how the ICSP started, and this is our museum. We have already seen. A lot of people come to the museum. This is our observatory. We have the largest telescope in Eastern India, as you know, and we will get the data also. Okay. These are the data we get from or balloon, I want to go straight to the point. I don't know what, yeah. So the universe is very big. Okay. Now we are ordinary animals in an ordinary planet and around an ordinary star. Sun is not special at all. Okay, it's a garden variety star, G-type star. In an ordinary garden variety galaxy, Akashganga or Milky Way. So there are virtually infinite number of places. There are lives. They are much more stronger, more intellectual than ours. So the idea is, you go for exploration like the many people are saying 3 IR plus, maybe intelligent. Maybe they are just moving around and try to find out who we are. So my idea would be, okay, just keep quiet and do your science nearby. Wait for others to visit you because there are almost 10 to 7 places in our own galaxy where the intelligence is much stronger, they are more intelligent than us. Statistically, okay? Now, if you go to solar system, you will see that how lonely we are. This is the sun. This is the sun, and nearby there are 70 stars or so. Within 5% there are 4 stars. You can see the approximate center. It will take 70,000 years to go there at the speed of Voyager. So, the point I am saying is very difficult. We cannot just say that yes, we will be an astronaut and we will go to that moon, that star and that planet, that moon or something. We will be very lucky if we can go towards the end of this heliosphere, solar system. Okay. Now, you can see the Voyager. Voyager started from Earth, and then it is actually somewhere here now. Okay, it's just about to get out of the solar system after 40 years. Average velocity is 6 kilometers, per second, and velocity of light is 300,000 kilometers per second. So you know how slow we are. Not because the technology was bad. Even today's technology, nuclear spaceship maybe 3 times faster. So, other possibility is that, let us say we can wait 20,000 years and let the Alpha Centauri comes close to us. Sorry, Proxima Centauri comes close to us. Possible distance will be 3 light years. Third possibility is that this GL710 will come to us after 1.36 billion years. Just keep quiet for 1.36 million years, and the star will come to it, but it will destroy the solar system. So our future, wherever you want to go, you have only 1.3 million light, not 14 million light. So the point I am trying to say is that I would like to feel that how tiny we are in such a huge universe, and that even the nearest star, it will take 70,000 years to go. So we are alone. Actually, we are lonely. Okay. Of course, there are people out there, there are lives there, but we are not being able to communicate. Because communication is a different story. Okay. We can look for the signatures, but communicate with them is a different issue. So, humanity really have time to explore the universe even the nearest? The answer is no. Even if we go into genetic makeup, we cannot no need, because even after 80 years, we don't virtually do anything. So if somebody is alive for 300 years, that means that you will be active. Okay, so by genetic engineering, you cannot do much. You want to go to alien, handle yourself, you don't know whether they will be friendly or they will just shoot you as soon as you do. So why you went all the way for 300,000 years, progenitor after progenitor and generating all kinds of things, and they will just shoot you. Okay. So this is a little bit dicey subject, or they may be friendly also. Stephen Hawking said that no, I am not going to handshake with an alien, okay? Because he does not know what will happen to my body or whether he will like me or kill me. This is a problem. This is a huge problem. I want you to think about it. The exploration part, the universe is not created for us alone. It's a huge universe, and we will be hearing that how people, even with all this, see, when our brains were developed 60,000 years ago, Homo sapiens, 300,000 years ago, Neanderthals, okay? We were just training ourselves to hide from tigers and just living in a cave, bite, eat something and go to sleep. The same brain, without changing the number of neurons, in fact, the size of the brain has gone up by 20%. Even then, we are able to understand the universe, the vast universe. That's absolutely huge. So human can do a lot of stuff. Okay. So I think that you think about the fact that what our capabilities, both in intellectual direction as well as in technological direction. The last question, I will stop very soon within a couple of minutes. We will survive. If ISRO says that yes, I am going to go to 2040 to moon, by that time the temperature of the water will may go up by 1.5 degrees again. Okay. You know that when I was born, after that the temperature has gone up 1.5 Fahrenheit, degree Fahrenheit. Temperature of the earth. The oxygen that was created by cyanobacteria 3.7 billion years ago, there is a sample there in the museum. We had last 200 years after industrial revolution, we have destroyed oxygen. We are now removing the Amazon forest, etc., and we are generating a lot of other stuff, which is very interesting. Having a lot of satellite links, Starlink, and other things to feed people's great page about internet, etc. Without asking the fundamental question that this earth is too small for maximum 3.5 billion people. Right now we are 8.5 billion people. And people like the businessman, Elon Musk, they are encouraging people to produce more so that we can scale satellite link. I'm just trying to say, okay, no problem. If the population is increasing, I will send some more satellites. That is not the way. Way is we must respect the earth before it gets out. Look at the temperature. Look at the way the temperature is rising. Absolutely high. This is the biggest problem. Climate change. So the moon is sitting there for 4.6 billion years. It is going to be sitting there for, by the grace of God, another 4.6 billion years. Don't question. It will be there. So do we have to go tomorrow, or do we first make sure that the earth becomes healthy? The earth that we lost. So that's it. Another very strong philosophical question. The government has to take a stand whether we should go to space or also spend equal amount of time and money, etc., for climate change to mitigate the climate change. That's a very serious issue. Temperature-wise, every year is warmer than the earlier year. So sad. Look at the way. Yes, ocean no longer absorbing carbon dioxide, it is emitting. Okay? Brazil forest, 70% gone. Alright, so how? Next time there will be oxygen farm. You can just have some oxygen cylinder for a while and then you will, there will be no oxygen. Now you want to go to space, colonize there. I don't like that. Because you have to take your pet, cats, dogs, all the birds, blue sky, green trees. You cannot just think of yourself. It is not anthropocentric thinking process. You cannot just think about yourself that I will survive, no problem. 20 people following Mars. Okay, that's not what art is all about. Okay. This is a big question, important question. Every parameter is increasing. So we have to ask this question very seriously. Earlier, one such board used to bring things for Bombay. Entire Bombay people would be happy with this. Nowadays, this kind of containers come every day, few times, just to in fact, some countries like Ulsan in South Korea, they boast we make the largest possible container carrier on Earth. Okay, for what? To feed more people, and more people means more carbon dioxide, less oxygen. So the point I am trying to make is that this is serious thing. Don't praise the government that you must go tomorrow to moon. No, government is doing. In fact, India is doing much better than United States when the question comes of climate change. We are producing 11% of the pollution, even though we have 1/4 of the population of the earth. So we are doing much be better than United States. Okay, so this is balanced country. All the things have to be thought about. That is what the democracy is all about. You be part of it. Now, so everything you look at the population. Everybody's population has started going down. All the intelligent people. Okay, although they are generating more coal, more petrol, but their population is going down. But the population is going up here. Our population will be highest, some about 2050. By the time the population will become like 10 billion. And then Africa will start turning over around the end of the century. By the time it's 2 years. So that question bothers all of us. And although you can think that it's a negative thing, this is not negative. I think we have to always think of the both sides. Okay, we cannot be just only one side thinking about it. So climate change is bad. Conclusion is that this is the universe is very old. Solar system is this and it will survive. So explosion, Moon, Mars, Jupiter explosion can wait, but must take care of this Earth. You can start by formation of the Mars. That's a very good logic. Can we convert the Mars into a habitable planet? Fine. But not because your population is high here, but because of your curiosity. Not because you have messed up this Earth and you want to escape from this Earth. Now that is not the excuse. Okay. So I will request our astronaut is sitting here. I will say that all of you are only discussing, yes, we must go to Mars or Jupiter or fine, very nice, but not at the cost of destroying the Earth. You are going there because it is there, but not because you have messed up this place. Now you want to get out of this place. Okay, that is the escapist way of doing things, and you should not be doing that. Okay. So this is our conclusion. I think that is basically I have to say, and I will request the next. I think you have the program. I think your talk. Please. So I invite our main speaker, the chief guest of this program from whom you want to hear, Group Captain Subhanshu Shukla. Please come to the dais and.
Take the right to the end.
Check. Can you hear me in the back? Yes. Raise your hands if you can.
Camera lighter, please.
Check. Good afternoon, everyone. আমি এখানে সাথী বিবেক বকাছি খুশি First of all, I would like to thank Dr. Sandeep right now for such a nice lecture. I'm very happy to be here. This is my first visit towards, after coming back to India, towards the eastern part of the country. And I think this is a great place to start. this conversation. Although I find it difficult to follow on after his talk, I was supposed to be telling you, get excited, we are going to the moon, we are going to Mars. He just told you not to go anywhere. So we have to save our heart first, before we get anywhere. But I think the sentiment has to be understood. I think it is a real concern. We are standing at a point wherein the data is becoming extremely visible now. And we have to respect that, and we have to be cautious of how we do things as we go into the future. So, in let's say next 20-25 minutes, I will quickly go over my mission with you. I will share my story with you. I am sure that you would also like to ask me some things. And since all of you are from this background, I am expecting some great questions as well. So let me finish this. I will share some things with you, and thereafter take on any questions that you may have. So, Professor was mentioning that Wing Commander Rakesh Sharma has also been here. He was the first Indian astronaut to go to space. He went in 1984, and I'm sure not a lot of you would have been around when he went to space. Even I was not around. I was also born in 1985. So I did not see that happen. But we were very excited. We heard about his stories. We heard about him. But what was being mentioned, the follow-up of that mission, there was not a human space program with our country at that point of time. So we had to wait 41 years when I went again this year in June and carried a flag to the International Space Station for the first time. And what was very heartening to me, when I was interacting with the Honorable Prime Minister on the space station, for the first time ever, Hindi was being used on the International Space Station. And that was very symbolic, and it was a very proud moment for me. And I feel that it was the journey of all of us together, and we reached the orbit, and now it is our time to make it happen from our soil, our launch vehicle, and our capsule, which we will do very soon. So I think we've heard quite a bit of wild explore by Dr. Sandeep himself, so I will not focus on it. But I would like to stress upon something. It is one thing to know that 100 degrees Celsius is very hot. It is totally different to touch something which is 100 degrees Celsius. That gives you some feedback. And that is what I realized when I traveled to space. We read about it, we understand it, we see it in pictures, we see it in videos. But by traveling to space, the perspective that you get, it is very different. It is not something that I knew. I had also prepared a lot for this space mission. But the experience was different. It was not what I had in mind. It was not what even I had imagined. And I think that is very important. And it highlights the fact that what Doctor was mentioning just sometime back. This is the home that we have. We don't have anything else. So I have an analogy. I've written something as overview effect in the last line. Whenever you travel to space, the astronauts have something known as overview effect. And this overview effect is an umbrella term to describe the change in thought process or the psychological shift that astronauts get when they travel to space, given that they have a very unique perspective. And for me, what that was, I would probably try to put it in very short form, would be the oneness of the planet, the strong feeling that this is our home, not a particular place, not a particular region, not a particular city, not a particular country, but this entire Earth, that planet, that feels like a home. And I was finding it very hard to explain it to people as to why should it be so, why should it be so difficult, or this feeling should be strong. And then I thought about it. Why do we think like it? So I have an analogy which I talk to people about. When we are kids, there are kids sitting here, school-going children. When you go to your school, your home in some ways is your identity, your parents, your brothers and sisters, your friends at home. And when you leave your school, you go to a college. To everybody in the college, your school is your identity, that you are from such and such school. And when you leave your college, you go to, in your jobs or somewhere else, your college becomes your identity. I'm from such and such college. I was approached by a gentleman who is representing some of the college here, representing some vice chancellor. When you leave your city, you go to some other city, you are from your city, that you become kind of, your sense of identity comes from your original place. And as an extension, when you leave your country, you go to some other country to work, your country becomes your identity. And very naturally, when you leave your planet and you go outside, your planet becomes your identity. And it's a very strong feeling, you cannot really miss it. And that is the closest thing that I could find of a good explanation of how to describe what we feel when we go out and when we look at this planet from the outside. So that is what is called as one of the effects of under the umbrella term overview effect, and that is what was very, very strong for me when I traveled. I've been told that there is no audio that is going to be playing, so the videos will not have the audio, but this is how the Earth looks when you are in space. This is how big it is. We don't realize of the sheer scale of these things. Although Professor was trying to mention in his talk of how big the universe is, but just looking at Earth from the outside, it is massive. It fills up your entire window. You cannot see the entire of it because we are very close. We are about 400 kilometers off the surface. But this is how it is. You see the sunrise and sunset 16 times a day, and you never get bored. I can tell you that. Let's move on to my mission per se, and like I said, it is one thing to prepare for it, and the other thing is to experience. Other thing is to experience the mission when it is happening. So we had practiced enough number of times in the simulator. I knew everything. I felt very confident. And we had also done a full test rehearsal 2 days prior to the launch, wearing the spacesuit, going up to the rocket, strapping up, everything, the entire cycle, even sitting there for the countdown, except that the rocket didn't launch. Everything was rehearsed, everything was known. So I felt very confident that, I know everything. But the data is that the engines would ignite just like this. And that data happens when the engines ignite on the final day when you're being launched. And when those engines come on, the 9 engines of the Falcon 9 rocket, all your preparation, everything that it just flies right out of the window. You forget everything. Because it is such a powerful moment. It is such a strong event that is happening. And when I speak to kids, I describe this feeling as the same that you get when you are sitting in classrooms and appearing for example when you see the question paper. All the preparation that you have had, all the hard work that you have done, everything you forget. Something similar. But the data is very important. It teaches you a lot. It teaches you that you can prepare up to an extent, but then again, there is going to be a difference which you will have to navigate when the time comes, when the situation happens. And how powerful it is, I have been a fighter pilot all my life. I have flown with machines. I know how the feeling is when something ignites, when you're sitting on top of a machine and you engage the afterburner. I know that powerful feeling. I thought I knew, but the scale is different, the magnitude is different. You're going from 0 kilometers per hour to 28,500 kilometers per hour in 8.5 minutes. And that is a huge acceleration that you feel, your body feels it. And under those kind of G's that you experience, it becomes difficult to breathe. And you have to specifically train for doing that. So it was a very fascinating experience for me to just go through this exercise. And we were very excited. It was like a high-powered, I would say, a roller coaster ride. And like kids, we were also screaming. Actually, our commander had to tell us to be quiet. She couldn't hear any calls that were being sent from the ground. And then after all this dynamism, you get to space. And when you get to space, it's extremely, in a second, it becomes extremely silent. The engines cut off, the state separation happens, you are floating in microgravity, and you feel nothing. It becomes effortless, absolute silence. It's not exactly silent, but you feel the feeling is such. And space is two things. It is a lot of fun. There is no doubt about it. It is extremely fun to be there, but it is also very disorienting. The concept of space you really don't understand. We are three-dimensional beings. We call ourselves three-dimensional beings, but Even if you look at the setting of this room, all of you are sitting on chairs. Everybody is standing on the floor. Nobody is hanging by the ceiling. Nobody is on the wall, right? But in space, you can do that. Then you really understand how to use the three-dimensional space. I remember my second day, I had to navigate across a module, and there was a NASA astronaut who was carrying out the experiment right in the center of the module. She had set up an entire experiment here. So there was no space for me to go. That is what I felt because I had gone from Earth. So I sat down and I was waiting. This other astronaut who comes up to me and she says that, "Shukla, what are you doing here?" And I tell her that I need to go the other side. And she says that, "Why don't you go?" And I show her, but she's in the way. And this one, she starts laughing. And she takes me by my hand, she takes me to the ceiling and tells me, "Walk here." And that is the time, your mind switches, it flips, it understands that this is how space is different. You are not restricted to one plane. You can do anything. So then we have started having days that today is the day of walking on ceilings, or today is the day of walking on starboard wall, and we will just navigate on that wall. So it was a lot of fun, but your mind has to flip. It has to understand because you are taking some habits with you, which is not applicable in the environment of microgravity. And the other concept is the microgravity itself. All of you would be aware that it is not that gravity is not there in space. There is gravity, but because you are in a free fall around Earth, that is why you don't experience gravity. You experience microgravity. And because everything is in a free fall at the same time, nothing is falling relatively. So if I was to hold this mobile in space and I let it go, it will stay here, it will not fall. But your mind doesn't know that. You got from Earth. So in the initial few days, if I have to leave something, I would search for someone and I would ask them, "Can you please hold it for me?" And I also had two first-time buyers from Poland and Hungary. And they are also thinking like me. So they would also hold it and float next to me. So while I'm doing something, all of us are floating in air. But they would be holding like this, standing like next to me. So that it doesn't fall. And this also you realize with time, how it happens that you can let go of things. Everything is going to be around you. It is not going to fall as compared. I hope this plays. Yeah, so look at this. I'm trying to change camera lens. Both of them are. How many of you felt when I was leaving the lens at the So this is what the mind has to get used to this concept when you get to space, that it is okay to let go of things. And after 6 to 7 days, you're really comfortable, you are leaving things, 10 different things, doing your work, collecting them back and putting them back into place. The problem happens, you come back to Earth with this mindset. And I remember first evening I was working on my laptop, I was replying to a lot of emails. A lot of emails had come, I replied, I was tired and I wanted to sleep. And out of frustration, because I had been replying to so many emails, I quickly shut it down, took it to the side and I left. That was a very, very quick lesson learned that this will not work here on Earth. But the important aspect is that the mind is very, very powerful tool. It can make you believe things that are not necessarily happening around you. It happens both ways, when you go up and even when you come down. And it takes time for your mind or your body to understand and adjust to this new environment that is around you. The other interesting concept is the concept of weightlessness. A lot of us would be very happy if we were to weigh ourselves in microgravity. Right? We will not weigh anything. We will be light as feather because there is no weight. But there is mass. You have to be careful when you are moving things. But you can lift heaviest of objects with just one hand. And that was one key attribute because of which we could make this space mission. Because it was not possible for us to send everything from ground at the same time. You could not put everything inside the modules and then launch them. They would be too heavy. So heavy equipment was launched later on, and the astronauts have assembled them while they were on orbit. And it was possible because there is no weight. You can move things around easily. But you have to be careful about the mass. And I have a video to demonstrate that. This is my commander, Dr. Peggy Whitson, who almost has 700 days in space, most experienced American astronaut as of now. And she's trying to move a heavy bag. The bag is bigger than her in a way, and it is used to transport heavy cargo. I will let you guess what is inside this bag, but you can look how careful she has to be to hold it. She can lift it, but she has to be careful of the momentum. That's almost 250 kgs of weight right there. How easily you can move it around in space. It's extremely fun. Good ways, very nice ways of explaining the concepts. You know how things are different in space. Oh. And I have one more for the kids here. You know, when you get bored, when the astronauts get bored in space, they also have some fun time. And if you don't have a ball in space, you use a human. These are some very interesting things that you can do in space. It really changes how you think about it. Again, like I'm telling you, when you're seeing this, when you're looking at it, it is one thing. But when you get there, it really rewires your brain of thinking about things very differently. And this helps a lot when you are making things for your own self. We are trying to make a space station. And this really counts. Because when you are designing something, you are thinking in terms of ground. You know, we need to put something here because this much space we need for a person to sit or stand. And then when I look at it, I said, you don't have to worry about it. You can just float in from anywhere and slide in from any side because you are in microgravity. You're not going to be using this thing on ground. So the experience really changes how you think about space. The body also undergoes a lot of changes. It has never seen this environment of microgravity. In the initial few days, all the blood from your leg, it pulls up, it goes in your head. You would see the image on the right. My head is swollen up. It has been because all the fluid has shifted to my head. Your heart slows down because it doesn't have to pump blood against gravity to your head. It will be a lot of blood otherwise. You are floating in space, but so is everything inside your stomach. So you don't feel hungry. I remember I had to force feed myself for initial first 3 to 4 days. And it was very challenging because you don't feel hungry at all. You also become taller in space. You grow in height. Because there is no load on your spine grows. And you grow tall by about 5 to 10 centimeters on an average. And every time I say this, there are some friends who are talking about each other and pointing to someone. And you need to go to space. I was also very excited. I'll gain some inches when I go to space. The problem is that when you come back to Earth, back to your original height. Only thing you get is back pain. That too twice. Even when we don't realize it, even right now, when all of you are sitting on these chairs and people who are standing, we are using our muscles to counter the force of gravity. We get used to it, we don't feel it, but we are. And you feel it when you're coming back from space. That is why astronauts take due to other reasons as well as this, that they're not able to walk. But in microgravity, there is absolute no use of muscles to count. There is no gravity, so you're not using them. So in my 20 days of space, I lost about 5 kgs of weight, and out of which 4 kgs was muscle mass. That is how quickly the degradation happens when you're in space. And then there are psychological challenges. As it was being mentioned in Dr. Sandeep's talk as well, you learn not to think about it, but the threat is real. You understand the risk. There are alarms going on. Most of the time they are benign, but you understand that if something goes wrong, there is not a lot of help available. You are on your own. You are in a confined workspace. You are working for long hours, isolated, cut away from everybody else. So these are all very challenging scenarios and environment wherein astronauts have to work. So you have to prepare very well. Case in example, Sunita Williams, she went there for a few weeks and she ended up staying for almost 8 months. You have to be ready for it. You have to understand, you have to accept these things. And that is what the training does to you. But we also have to solve these issues for us as a country, when we are planning long duration missions, going to the moon and eventually beyond. And these are challenges that we have to address. We have to navigate these challenges. How do we solve these problems? And these are complex problems to be solved. The other aspect of my mission was conducting science in space. For the first time ever, the Indian researchers got an opportunity to conduct science on the International Space Station and bring back the data. And I was very happy to be a part of it, to be a bridge amongst them and the orbit, and conduct these experiments for them. And what does microgravity give you? It gives you a very unique environment. Biological processes, they become faster. Physical sciences and engineering, this growth becomes much easier. The water, if you spread water, it is always in the form of a bubble. The flame, if you build a fire, it is going to be in the form of a round shaped fire. So all these things give you a very unique insight into existing problems that we are facing on Earth or challenges that we are facing in terms of experiments. But more than that, I think what are the results that we learned? What we learned was how to enable an experiment in space. That in itself is a huge challenge. What we can do something simply on ground in a lab. If you want to do the same thing in space, it's another challenge altogether. The experiment, the myogenesis experiment I did, one of the experiments that I did in space, again, you look at the problem of muscle atrophy. It was such a complex experiment that had to be done to contain the fluid in a container, how to provide nutrition to it every second day, how to keep it in the refrigerated environment. Everything has to be learned. Even the smallest of things, how to use syringe, how to use pipettes, everything you have to learn and you have to understand how to enable it. So I think that was our biggest learning. We understand now how does it happen. How do we make it happen when we make our own space station? And after doing everything, staying there for 18 days, 19 days, it was time for us to come back home. And we were very excited for that. I actually kind of did not want to come back. I was very happy there. It was a great place to be. It is very peaceful. It has an amazing view. And you would really understand and you start enjoying the things after a few days and then it becomes alright for you to stay. But all that energy that I was talking about, when you go to space, when you want to come back, that has to be dissipated. You have to stop the vehicle. It is moving at, say, 8 kilometers per second around the Earth. How do you stop it? You stop it through the atmosphere. And when you stop it through the atmosphere, it generates friction and heat. And that heat is not ordinary heat, it is almost as hot as sun, 4000 degrees plus. That is the kind of temperature that is around the capsule. So the entire capsule becomes a big fireball when it is gestating in the atmosphere. I was, for one, very excited to look at this fireball. How does it look? Because you have two windows in the food dragon. So when you look at it, it starts yellow, small flames, and then it becomes steady stream, changes color from yellow to red, orange, purple, all shades you see when it is growing. But what was very interesting for me that I had to strain my neck, lift my neck slightly to look at this fire. And after some time, I really felt a lot of strain, a lot of pain in my neck. And I thought that we must already be under 3 or 4 Gs right now. That is the kind of pain I was feeling. Again, my background, I am not unfamiliar with G-loads. I have been doing it all my life. But when I dropped my head back and I looked at the display was reading 0.3 G. It was not even 1 G. And that is the kind of shift, that is the kind of effortlessness what I was talking about. When you try to open your eyes when you're coming back and immediately after coming back, you can feel your eyelids, you can feel the weight of your eyelids. That is the kind of difference in effort that is there in orbit as compared to ground. And when you come back to Earth, again the same thing. As when you go to orbit, everything is new for your body. Now when you come back, the Earth becomes a new environment. And it is difficult for you to get used to this, to adapt to this. And this is a video of me 2 hours after splashdown. And immediately after splashdown, I'm sure you would have seen in the videos, as I'm coming out, I was not able to walk. Even though I felt okay, I was not feeling bad. I was feeling quite okay, but I was not able to walk because my body, my mind has forgotten how much effort it takes for me to stop from falling. Every time I put a step, I will fall down because I don't know what muscles to exercise to keep me from falling. This is 2 hours after this match. how challenging it becomes. Both the sides, your body has to relearn. Yeah, you have to adapt. And depending on your duration of mission, you spend some time in rehabilitation, learning how to walk again and how to come back to normal life. And that is the time you get there from doctors to resume your normal day-to-day activities. So what is the purpose of this? This mission that I went on, I'm coming here, I'm talking to all of you, we're sitting here and we are discussing all this. We already have a roadmap of what we want to do in the field of space. We have Mission Gaganyaan, which is launching an Indian into space and bringing them back safely. And after that, we'll have the Bharatiya Antariksh Station, which is making our own space station. And eventually landing on the moon by 2040. This is all laid down in the Space Policy 2023. But these are not easy tasks, or these are not easy goals. These are extremely challenging. And who will make it happen? People like you who are sitting on these chairs and benches. And this is what I'm talking about, what has been decided by the government. Parallelly, there is a huge ecosystem of the private startups who are coming up, who are trying to explore. And I would like to highlight some points, what even Professor Sandeep was mentioning in his talk. I will add on a few reasons why I said, why are we going to explore there, first we need to save this. I think it works parallelly, it has to work both ways. Because when you go to space and when you try to solve problems in space, you actually end up solving problems on Earth. We don't even know. These are unintended consequences of you trying to do something extremely complex. We don't even realize that we have gifts of space travel, GPS being one, that we use every day. Now navigating and going on streets without the GPS, it is something you can't even do it. But this all started from here. Even thinking is a gift of spaceflight. The Velcro that we use on all our clothes. Battery operated power tools are a gift of spaceflight again. So, very small examples I am taking, but there are many more. But it happens so that when you try to do something which is extremely difficult, what we are trying to do when we are going to space through human space missions is we are trying to create life in an environment where it should not exist. There is nothing. We have to provide air, we have to provide water, we have to provide everything artificially. So when you try to solve such complex problems, you end up solving many more problems here on Earth. These are the unintended solutions that you get, which you did not even think of in the first place. And what will happen when we do this as a country, as a nation? You take a big problem that you want to solve. And how do you solve that problem? You have to start by targeting education. And that comes to the first level, the first pillar of the triad. Solve the education, give the right education. This education gives you the right workforce, skilled workforce available. And that skilled workforce goes into the industry. So this triad, it comes up together and it lifts your entire nation together, towards prosperity. Not just going to space, but also solving a lot of problems here on Earth. Some of this I've already mentioned, but to the children who are sitting here, and also what you were mentioning, that not everybody will get to be an astronaut, and that is true. Not everybody will become an astronaut, but an astronaut doesn't travel to space alone. It is not possible. When I went for my mission, there were thousands of people sitting all over the world who made that mission happen. From mission specialists to nutritionists to designers to engineers to technicians. There are so many people sitting all across the world. We travel to Japan, Germany, US, India. People are sitting and supporting this mission. That is the kind of effort it takes, and everybody is a part of this mission. You see the face, obviously, who travels to space, but all of these are required to make it happen. So even if you don't be the astronaut or ghost, you still can be part of the journey. And that is what is exciting. That is what is going to happen when we develop this as we go into the future. We are going to create a lot of jobs. All the fields that I've written on this slide. You can be in any discipline, and space still has space for you. That is the kind of potential that it has. And why do we do all of this? The overarching dream that we have of Viksit Bharat 2047 that we have written. I feel that space exploration is really going to be a very big sector which will help us achieve this dream. And you are all going to be the fuel for this. So on this, have accountability, believe that it is your job, it is my job to take us from here to the dream of Viksit Bharat 2047. And on that note, the last thing that I've not spoken to you about is, one of the reporters I think asked me this question, repeated question, second time, ऊपर से भारत कैसा दिखता है? How does India look from space? And rather than telling you how does it look from space, I would rather show you. Okay? So I will show to you how India looks from space. It is a night video. If you want to record, no flashes. Okay? And if you can switch off this light, it will be good. And this is a night video. You will see the curvature of the Earth. The green glow. The green glow is due to the oxygen atoms in the upper atmosphere. And you will see flashes of lights that are happening. These are essentially thunderstorms or lightning that is happening on the ground. And we will pass over India. I will point out, Bangalore, Hyderabad, Pune. We will see these bright cities, and then very quickly we will cross India, and you will also see an orbital sunrise. Yes. So the curvature you can see, the green glow is due to the atmosphere, and the flashes that you see are the lightning that is happening on the ground. And this is India emerging. The brightest city that you see is Bangalore, and on top of that is Hyderabad, Pune on the left. And you see these bright flashes happening. And we've crossed India. And that's the sunrise. With this, I would like to conclude by saying what I said from orbit in my farewell speech. We are really standing at a point in our nation's journey which is very exciting. We are going forward with determination and with capability, with resolve. And I feel extremely proud to be a part of it. So to all the kids and everybody who is sitting here, my message to you is this: what I gave from orbit, the sky was never the limit, not for me, not for you, and not for Bharat. Jai Hind, Jai Bharat. Okay, so we had absolutely fascinating talk by Group Captain Shukla. He is like our hero, and now the process, the list and list what we want to do in about 1 hour. In about 1 hour, what we are going to do. But I think that about levels of beliefs, you cannot, and not only it is grown down. I don't know.
It will, okay. Our program right now is that we will be sitting here, 4 of us. I will invite Dr. Joydeep Mukherjee. Is he around? He was here. Sorry? Okay, please come. So, right now, our program is following, okay? Let us not have fear. I know, but how many people want to show up? When he goes out, then he can always do that. Now, let us finish our program, then you can do it. Let us finish our program. After that, you are free to approach him. He is very generous. He has been giving, he is basically following his. So, our Dr. A.C. Chakraborty, please come. So, what we will do is, we were supposed to have a tea break, but instead of that, tea break, if you go out, have tea and come back, we will be wasting time. So I request that after this program is over, we will have a program will be over by let us say another 40-50 minutes. After that, you can go out and have tea. And right now, we want to start the panel discussion on why do we go to space. আমরা মহাকাশে যাই কেন? ঠিক আছে? So after that, there will be interaction session. Namely, all of you will be allowed to ask questions only if they are a little good type of questions. So you should also know how to ask questions. Now I have a large number of questions here. What I will do is, I will call the name of the people who already wrote the questions, and they have to select a source list here, so that you should come right here and have a mic, ask the question. So when the question session comes, okay? So right now we will spend about, let us say, 15 minutes on. Also, you're tiring, you are standing there for a long time. We are just sitting a little bit and discussing on why do we go to space. Let us say 15 minutes, and then slowly it will become an interaction session, and then we will finish. Okay, another let us say 40-45 minutes, and it will be still earlier than the program, and after that you can take tea outside. Now, the program will go like this. All of us, starting from you, and then Joydeep Babu, he is from NASA. He's from Florida, you met him, and so he is sitting there. Okay, came together. So all of us will say about, let us say, 3-4 minutes of speech. Only 3 or 4 minutes. And why do we go to space? You make your point, he makes his point, I make my point, and you also make your point. And then from there some questions may arise. And from there, after these questions, we will go into the main question session. Okay. So these are basically question sessions, but focusing on it, because sometimes I have seen the debate in big channels. It's a wastage of money, and big channels that are the pro and con. It's a political game, this and that. So this question is, why do we go to space? So what is your opinion?
Thank you. Why do we go to space? There is only the question is that why should we have man space flights, or why should we send human beings to space? Basically for human beings. Now the question is that from the beginning, that Cold War, where the Apollo mission was conducted by Americans, and the Russians also were trying to go to moon. So that from that question is which was quite earlier days, of space research in the world. And that time itself, they realized that it is better to send human beings, even though the technology was not as much developed as it is now. And there are reasons for that, why we send human beings to space. One of the reasons being that decision making, the robotics, alternatively send the robots, and we have much better artificial intelligence and then machine learning and all these statistical methods which have come up. And it will almost mimic the human brain, and they do the work of human beings. So why should you send human beings to say moon or around the earth to do certain work? It can be done by robots. So the question is, robots, there are limitations in the robots. Limitations is they cannot make the instant decision making. Like for example, the moon, a lot of discoveries made on moon, like geological features, its terrain, its soil, ecology, all those things we didn't know what really do. Unless the astronauts have stepped on the moon. And the point is that the new things, the robots should not be able to take decision. Or after seeing some experimental results, what to do next to find out, explore in a better way, or more exploration, which will not be possible by the robots to be done. So that's why human beings are required. One thing. Another thing is, we have set up a lot of instruments, or even the astronauts have brought here and set up a lot of instruments, for example, on the moon, to understand the moon's evolution and even the solar system, how it started and how it gave rise to planets and moon and the satellites, etc. And those instruments, even we did not know that there is a seismological features on moon. A lot of seismological instruments are set up by the astronauts, which is not possible otherwise to know. So these kind of features will not be possible by merely sending you. Yeah, I agree that robots can do a lot of work because the robotics will further develop. But human intelligence cannot be replaced by the robotics. So that is one thing. Another thing is the overall prestige and development of the country will largely depend in future times on human missions rather than sending a satellite and doing some robotic studies. And also it will have implications on the overall structure and the overall geography and the politics of the European nations. That what human beings can do from space, and each country will like to have that power. Like the nuclear devices, people like to avoid. So these kind of things will become important, and also for peace purposes, cooperation, international collaboration, because the human exploration is not possible by one country, and now it is demonstrated by Artemis, for example, project of NASA, who will be sending the human being now again after such a long time to moon, because the moon is the next place where they can explore further other planets. Planetary exploration will not be possible unless people go there. Like as I mentioned on moon also, it was a problem that we didn't know anything about moon earlier. Even though it is the nearest heavenly body. Now, so these are the things, and also the young generations. It will require a lot of activities from engineers, from economics, from managers and scientists, and all have to work together. And a lot of employment potential will be there for the young generation. The education and learning, which in progress, will be tremendous, and that will be an inspiration. to younger generation for future. So simply sending a doll kind of robot may not be as attractive or as sustainable to maintain the interest of youth and who need to be attracted because the space is going to be the next frontier, as Subhanshu has already mentioned. And so if it is the next frontier, without human presence, it will not be possible to achieve the goals what we intend to achieve. My name is Subhanshu. I work in Oslo, and my last project was Chandrayaan 1, and I retired in 2009. 2007, and 2 years I worked further. And now I am actually the senior professor of ICSP.
Also one of our governing body members, and we get a lot of advice from him. So let me say something about why we go to space. I am Sundip Chakraborty, director of this institution. Now, you know, sometimes people say why go to space, and a philosopher will say, okay, because it is there. I want to go because it is there. I must go there. I have no reason. I don't have to show any reason. Space is there. I must go. Okay. So that is the reason why you go to space, as far as I am concerned. Okay. Now the question comes that what is space? As soon as you jump from your from the stellar hard surface, you are in space, obviously. Okay. There are definitions. When you go to, let us say, mountain, 9 kilometers only, Himalayan mountains, you need to take some oxygen and so on. You are already in trouble. There is a small layer on Earth. If you leave it, you are in deep trouble. You have to take all kinds of precautions. And then people have defined space. Americans have defined a space, carbon line, 100 kilometers. If you cross, you are probably 643rd person. 34, so 43, I mixed up. So 634 person who actually crossed 100 kilometers. It is so, there is a cardinal line. There is nothing special happening there. But somebody said, no, at least there should be a number. Why? Because below that, you will see it is an airspace. The boundary of the national boundary actually projected upward. You cannot cross boundary of the nation below 100 kilometers. Above 100 kilometers, you can cross, you can have a satellite, and do all kinds of things. So the nationalism comes only if you are below 100 kilometers, below the carbon line. If you are above carbon line, you really don't have any nationality. You are a human being. When Neil Armstrong landed, I was 5th standard student, 1969. I was extremely just excited. Not because he is not an Indian, but the fact that a person like us, imagine yourself, the person like ourselves, in an individual who, for all the challenges, are going to the most hostile place. Okay? The frontier, the fighting place, that is the front. So they take the frontier up for us on behalf of human beings. If the aliens fight there tomorrow, if the aliens, attack us, we will not say no. It is they are attacking Vietnam, so we will not care. Or it is attacking Ethiopia, I am not care. That is not true. It is we versus them. All the countries will be going together because it is Earth versus alien, Earthlings versus alien. Okay. So these aliens are there. We are aliens with respect to us, and we are aliens with respect to them. Even this ICSP actually has this idea that the Earth should not be treated as a very special planet, but it is a planet, and its relationship with the rest of the universe in all possible ways. Okay. Now, why do we go to space? There are 2-3 things. As I said, because it is there. I like to know how the galaxy is formed. Few days ago there was a news, that all come on that was discovered, Algonanga, only 100 crore years after Big Bang, all structures spiral galaxy has been formed. People thought that after long iteration of the evolution, you need a lot of time. No, only 1 billion years after the formation of the universe, already spiral galaxy like our own galaxy has been formed. Do we understand our universe at all? Or is it that partially, how is inside a black hole? You see, recently, all kinds of these questions are coming up. Every day, James Webb Telescope is bringing results. And we are feeling that, do we really understand this universe at all, or we have to start all over again? People say, no, nothing like Big Bang happened, but they are not sure. Situations like that. Royal Penrose is not true. But he says that most of many things we see are not from started after Big Bang. It is the before the Big Bang, when the universe, the Big Crunch, the Big Bang, and Big Crunch. The eternity question to what was the universe before that? That question does not arise. So why do we go to space? We go to space to send instruments like James Webb. We go to space to send instruments like Parker probe. Aditya L1, we have gone only 1% of the distance between us and the sun. India has a limited capability. First thing, they have put in Aditya L1, only 1% distance. Parker probe already going 96% of the distance towards the sun. It is inside the corona. So that is, and every day, every picture, every video, every data is giving us new things. People are saying we never knew that this happened. So whatever you do theoretical things, when you actually confront the reality, then you see that things are different and much more complex. And therefore, and if people go there, because brain is 100 times sophisticated than a machine that we do. Okay? Machine is very limited compared to what we have this faculty here. So that is why we must go to space. But how far can we go? How fast can we go? And I always ask the question, even 20 years ago, we put all the money of all the countries in one kit and give it to Elon Musk or somebody. Just go to Alpha Centauri and tell me what is that. Okay? Oh, I don't have to go. Maybe India has missed the bus. Maybe China is also missed the bus, or who knows. At least they should all the key together. Don't divide, don't say that no. Indonesia, I'm Indonesian first, that went there, Vietnam is went there. No. That is one thing, that is very good. That is why you are here today. Because among you, there is somebody like us. He also likes chapatis and you are eating like us. But he conquers this. Okay? That is why the nationalism comes in. But when you say no, the knowledge sector has to be improved, then don't worry about nationalism. Then combine together, don't fight about it. Like here, Igor Kapu, Slaus Uznowski, and our Dehi Whitmore. All these people, they were behaving like, they are behaving. They are not like somebody from Poland, somebody from Hungary. Because when there is a problem, they will not say, no, your prime minister hates my prime minister and I am not that. You cannot do that. So we go to space. On the other hand, there are some other set of people who are making money out of this. That is why sometimes I always look at both sides of the story. People are sending CanSats, nanosats, etc. and they are very proud. My fourth class grade student can make nanosat. How many of them you want to see? This stupid planet is only 12,000 kilometer diameter. Every square kilometer, if you put one nanosat, if you have 800 billion people, 8 billion people, if all of them want to say have their own nanosat, and then so no, I want to have my own star. While you watching Alpha Centauri, you watch the Proxima Centauri, you watch is the something. So everybody just like have cell phone, everybody may have their own satellite one day. I don't mind to have our own satellite, each of us. But the number of population must be lower. Otherwise, you will crowd it in such a way that it will cause huge disaster. So there must be responsibility. Only those satellites which are very much useful to real explorations, etc., we should send. And responsibility is very much should be there. And the other set of people, they want to make use of use of space, which is, by the way, of humanity's property. As I said, above 100 kilometers, it is humanity's property. If you get money out of that, distribute to the humanity. Pay 100% to the government. Look, I made this money, so they take this money. So when somebody like Musk or somebody says, no, let the population become flies, I will supply the 60, 70, 10G or satellite link, he is making money using this space. That is why I don't want to supply. Okay. But if you say, by all means, go as close to the sun as possible, go to Jupiter, dance around the Saturn's moon, I have no objection. But if you say, no, I want to get out of this part, then I have objection. Don't get out. This is the only place on Earth, only place in the entire universe we know that there is life. So, and there is beautiful sky, there is wonderful birds, there are wonderful kids. And they came much before us, 20, 30, 42 years before us. We are the dangerous set of animals. Okay? We are killing them, we are thinking about us only. And so let us be passionate about this planet. We go to space, dump all the money, send somebody there. Make the fastest, smallest wheel. I have no objection. But it should not be at the cost of destroying these communities. Okay? So that is my 1 minute lecture. Okay. Now,
You should be the last class.
Thank you. Thank you for the invitation. I'm on vacation, so I'm not dressed like everyone. Best shirt and pant is fine. So, only very different perspective. I'm the director of the NASA, Royal Space Flight Consulting, and I represent all Royal Universities in NASA. So I work with students from kindergarten all the way to postdoc and faculty. I support research among faculty. I give scholarships and fellowships to students.
Take the mic like you do.
Closer? Is that better? Okay. You didn't miss anything what I said. So anyhow, why do we want to go to space? And now 3 or 4 points. First, Dr. Chakra talked about that is our place in the universe. Okay? This is how insignificant we are. We're learning new things about space. The James Webb Telescope has found black holes on 200 million years after the formation of the universe, which defies all the ideas we have about galaxy creation and black holes. We also want to know, are we alone? I mean, that's the most fundamental question. That makes us different than any other species on the earth, is we want to know, are we alone? Someone else out there. So that's the how we are in the universe. The second thing is, with space, we have what is called spin-off from technologies. Most of the things that we're using in this room is due to space, is due to exploration. Whether it's GPS, whether it's medical imaging, whether it's materials for robotics, space spin-off technology has really helped mankind. And Captain Shukla did talk about how unknowingly working on space helps people in the earth. The third point is protecting the earth. So Dr. Chakrabarti talked about climate change. We have to worry about it. There's sort of politics in climate change. So in the US, there's an issue with climate change with the president administration. Not so much in India. We worry about that. We have to worry about asteroids. I know the asteroids only come and hit the Earth right now, but we have to keep a lookout for the asteroids. And that's what we're doing. There's been a new telescope called the
Weird Rubin's telescope in South America, and within 10 hours, it identified 2,000 asteroids, 7 of them which will be crossing the Earth's orbit. They will not cause any problems. What I'm saying is, with better technology, we can find more asteroids, and we have to figure out a way if any one of them are coming towards the Earth, how to deflect. The next one is space economy. The global space economy was about 570 billion in 2023. In 2024, it went to $610 billion. But the project by 2035 is going to be $1.8 trillion. So it will be all a part of it. There are so many startup companies in India who are building rockets, who are building satellites. So any of the kids who grew up in college to be a part of this economy. Finally, Dr. Chakraborty talked about national prestige. So that's another thing, is prestige. You know, we want to be Pakistan. The US wants to be China and move because national prestige plays a big part. And it helps in giving us more money in the budget, just because we want to be before another nation. And finally, it's the kids out there at the back. Space inspires more than any other topic I know. And I can just tell you right now, when I was sitting in the front row, there was a small girl sitting next to me, and she was looking at the pictures that Captain Shukla was showing, and I could hear the words, wow, how have you done? And that's what we need to see. We need to see kids getting inspired. And I can tell you, I've been working with kids for the last 25 years. The fact that you are here and in the other two halls makes a big difference, because that tells me that you are interested. And you don't have to go to space. But I know all of you who are in this room right now will be successful because you have taken the extra step to come and listen to all of us. And I'll stop right here.
Thank you for this wonderful topic, I would say. I have also learned something since the time I have been here. Whenever Mr. Sandeep says that he is just going to speak a few words, he never few. But they're very wise words. But very wise words. Whatever points you have made. The points that he said highlighted are very, very important in the opinion of why do we go to space. I think partly all the points have been addressed in some way or the other. During my talk as well, I said this, and what Professor Sandeep was also referring to. The human mind is very curious by design, and if we don't have problems, we create them, and then we try to find solutions, which happens in everyday life as well, and at a bigger scale when we talk about exploration. But if it is there, if space is there, it is there, so you would like to go. If it was not for this spirit, we wouldn't have ever crossed oceans. We would not have ever ventured out from our places. So I think that is the inherent nature that we have. The second thing, since we focused on human space missions, and I have tried to highlight this a little bit in my talk, the human space missions, I feel, are not a change in data from a normal satellite missions or rover missions. They are a change in time of how you need to think about it. It's a totally different scale, totally different magnitude. And again, because of this, it becomes extremely complex, and as a result of pursuing these complex things, you end up solving many problems that you didn't even know of, which what you are referring to right now, the spin-offs that we're talking about when we do space. There are many reasons, all of them have been covered, but I would like to focus on one aspect only of this particular thing. During my stay in space, during these 20 days, I interacted with kids twice from India. And in every interaction, there were questions about, how do you sleep, how do you eat, what do you drink water, and everybody is excited and fascinated by how things are happening. But I had a very peculiar question in one of the interactions from a boy who was from the northeast region. And his question was कि सर भारत के नॉर्थ ईस्ट क्षेत्र का छोटे से गांव का बच्चा एस्ट्रोनॉट कैसे बन सकता है? How can a small boy from a small village from a northeast region of a country become an astronaut? And I think this is what I want to tell, the power that it holds to the space missions. When I crossed the carbon line, so I was mentioning that 634 human to go to space. Now, when you are 634th on any list, it is not something very significant. I was kidding, what's the big deal about it? Why are we celebrating? I generally felt like that when I was there in the US. Why such a big deal? Because there, the space travel is pretty common. People are going to space and coming back. But when I came back to India and I was visiting my school, there were two kids who came up to me and they said that, sir, we didn't even know about ISS till the time you were not there. We came to know because you went there. We started watching because we were seeing you there. And I think this is what it does. It gives the belief to somebody who's sitting in the last row who I am looking like them. I talk like them. I'm eating the same food. I like chapati, like you were saying. Eating the same food, doing the same things. So when you see me going there, it gives you belief that you can also be there. You can also do this. It allows you to have that confidence, and this is within my reach. And I think that is the power. When this mission happened, I think I was not expecting it, but I know now that the entire country felt proud. And that is the power. It brings together. It's symbolic in a way. So when you launch one person to space, I think you lift a million here on Earth. That is the power of space missions, and I think that is why we should continue to explore and we should continue to go out. Thank you.
Because say we have already, all of us have been there. Then what? So, should we not continue to go even higher? Let's say again, after that mass. So the point remains that do you have any answer to that in foreseeable future you can really go to one of the nearest stars? Because at the end of the day, I like to play on properties in the planet. I don't know about you, but I like to go around the planet. Can I do it? What my generations? One of the good things about this subject is we always call it a mission. Mission number this, like Ramakrishna mission. Mission means you don't have to go. You just go a little bit, but you have a goal there to go there. But you don't have to. You do your bit and advance the subject a little bit. The next person comes, advance the subject a little bit. Okay. So that is why it is called mission. You have to understand it. Now they like so same they teach about Jesus Christ's thing or Ramakrishna's things. They say, no, I will die, but the next person we can do. Here also, little by little, persons like group captain taking the torch ahead. Now the question comes, in foreseeable future, let us say 1,000 years. Do you see in what direction you have to give a solution? Not just that you think that you should be able to go, but around that line you should be able to go. Which direction? Is it genetic engineering or it is the nuclear power? I mean, we are not being bored. Time travel, how are we going to go to Proxima Centauri?
Actually, I think about these things in a very different way. I agree to the first part that you said, and I think this has been in our teachings for thousands of years. Our scriptures, this has been written. You do what you can do, focus on your work, don't worry about the outcomes. Don't worry about what it is going to take you in the future. You do what you're doing as good as you can do now. That's all you really can. What is going to thousands of years later is really not in control. What is going to happen tomorrow is not in my control. Let it 1,000 years. But we did have this idea of what you said in this 1,000 years. I think there are a lot of challenges, a lot of problems that we need to address. Proxima Centauri is really far. Even when we talk about going to Mars, let's see. So going to Mars is a 6 month travel one day, and coming back, and then staying there. So 2-3 years timeline we are talking about if we have to send someone to Mars. And in that time period, the kind of radiation that the people will be exposed to will be extremely high, will be prohibited as of now. So these are the problems that we have not solved yet, even when we talk about Mars. So I think Proxima Centauri is so far away that I think the propulsion that we are talking about, the time that it takes for us to get there, how to preserve some Mars. So this is what the problem. When you talk about genetic engineering, or when you talk about advanced propulsion, or time travel, or wormholes, or warp drive, whatever it is, whichever concept, whichever theoretical concept we talk about, the challenge is that we don't have enough time in the human lifespan to reach there and do something new.
Generation after generation, only way.
So you either evolve on the way and then you get there. But imagine, spending your life in this, going somewhere, reaching there. So I really don't have a clear answer to this. I don't have a clear way forward that what is it that we should pursue to enable that. I don't know. But I am confident that if we keep working, possibly solve problems that are closer to us, and then that will give us insights, which will open the next door and then the next door and then the next door. And then we will go forward. But if you want to ask me exactly whether we should be doing biological way or we should do technical way, I don't think I have a great answer for that right now.
Anybody want to also make one or two statements about this? If they completely different view than what is also welcome. You can come here and then, or you can send it mic.
Yes, so I think it's going to be difficult to aim for the nearest star. It will be maybe generations from now. And I'll be happy if I can go, say, to Europa or on the moons of Jupiter or Titan on the moons of Saturn, because I believe there is a chances that there might be some life form because there is water under the crust of ice. So that's if we can aim for that, then eventually maybe as we go step by step, the next step will be when we go then to the nearest star. But it has going to be a big, these baby steps. Now I know there are some faculty who are working on propulsion. Right now, there's some faculty that I'm supporting who's going to provide some kind of a hydrogen engine that can take you, say, from Mumbai to Kolkata in about 20 minutes. So, not for stars, but that's the baby steps. You get these baby steps. We do this. We go to Europa, then we go to Pluto, and then figure out how to go beyond. Now, we should always have that in the back of our mind that should be one of the goals, even if it's not retained in the next 2 or 3 years. But it can be done because we want the kids out here to think about it. Because when kids come up with the craziest ideas, but maybe 99% won't work, but the 1% will listen.
So, one thing that Captain Shukla said is very important, the radiation damage. Very recently, the Chernobyl, after the Chernobyl reactor, they found a lichen kind of thing, which is sustaining the strongest possible nuclear reaction. See, it happened 1986 or so almost 40 years, and there is a lichen which is surviving that radiation, and the life is there. They are taking that lichen, they are thinking of putting that around the spacecraft so that inside maybe safe. So I'm sure the one after another solution will come. What about Einstein said? See that kilometer per hour. So now that's a law which I have not seen anywhere violated. What to do about it? Okay. So there are certain things which I believe that we are stuck on this planet because we have been created to be with the parameters of this planet. We are co-evolved with this planet, with the sun, with this moon, etc. And we are stuck. Anything you want to go out of this, you have to work very, very differently as Captain Shukla said. So the point is that because, as you know, that even in visible light, our eyes are also sensitive to the same visible light that the sun is from. Okay. Otherwise, we don't able to see. Our eyes are only, they can see only infrared, and sun, when it is visible light, it's no good. There is no day and light, it's different. So here we are stuck here. Now, fundamentally, can we really get out of this place and thrive around? That is my biggest goal. It's not that the technology will not take us there. Okay, that is my problem. That because all the parameters that we have. By the way, I want to ask you a question. Have you come back to normalcy? Are you a normal person now? After 4 months, all your parameters have become completely doctor is satisfied that yes, you have become human being again. How long? Because you said in still time. No, because you said only about 2 weeks. 20 days. But Sunita, we have about 45 days or 1 month. So the home has to go for. You have something to say? Otherwise, we go directly to the student.
Your question that 1,000 years. What is your percentage? I mean, your 50 was perhaps to go to the nearest star. Now the problem is in space, you cannot plan very long ways because what happens is in between developments, like in ISRO also, the first department which had a 25-year plan. There is no other department in India which had a 25-year plan. We could think of 25 years ahead to achieve what goals and do accordingly the work. Suppose there is slippage in time schedule. 1,000 years, definitely I can say that we will go to Mars. But I cannot be so sure about going to be near a star. Very high speeds are required. The propulsion systems will have to be totally changed. You have to almost compete with light velocity. Even to reach the nearest star in 80 years, it will be 80 years. As per the realization of the technology which can be achieved. So, the space you will have to first achieve, if you go to Mars, and if you are able to do it successfully, then you can think of doing something more. Not before that.
Question remains that once Sunita Williams was start, all the headlines of all the newspapers are on Sunita Williams. Only 400 kilometers away from us, one lady got stuck, and we stopped our job. Now because if somebody goes to Mars, boy, all the governments will stop, all the parliaments, all the if no, first we want that person to come back. Okay, that is the biggest problem. We have to just let them go. There are some volunteers who we have to go at one way, and then. By the way, so if you have any question on this issue, otherwise we go to general category. Fantastic. So what the process will be, I will ask some, I will sort of follow up the names. Let us say Sachin Kumar Mahato. Is he around? Okay, please. No. Let them ask, but the team will start to ask, but they will take the day after going on. No, they cannot all the questions. So, Mahato, I done. You have. I never see it. Never see fine.
Hi, sir. My name is Sachin Kumar. I'm from MCK school. I'm from MCK school. My name is Sachin Kumar. So I had a question that what would you say about the new discovery of another universe galaxy? which was discovered by two Indian scientists and astronomers. So what do I say about that?
Your question should be for Mark. No, wait a minute.
One question.
No, wait a minute. Your question was, I thought, see, we are, these questions are one better. Don't improvise. It's a very good question. So, you are.
Sir, okay, I will ask that later.
I was-
What one thing would you like to change in the Indian education system? If you had a chance to change, to give the Indian students all over the country wide good opportunity to practical knowledge and good information about space and other technological advancements.
I think you've answered your question yourself. When you say practical knowledge, I think this is what I would like to change. The way we teach is mostly sitting in classrooms and reading from textbooks, and I think it is not exciting. I did enjoy it much when I was a kid. So, if we can change to a more experiential form of learning, and rather than teaching specifics about something, we just give a vague idea and let kids figure out the problems on their own and develop the skills of how to answer the problem, rather than what is the answer of a particular question, like what is the name of something. It is not something that is extremely important, but if you know how to figure out things on your own, like problem solving skills. So spiritual based learning, which translate into real skills, which are actually utilized by real world jobs or applications in the industry, and that is what I would like to change, which I am trying to do. Thank you.
Sir, very glad to talk with you, sir.
Yeah, okay. Govind Das, মহাদেবপুর কেন্দ্রীয় আদর্শ বিদ্যালয়া গোবিন্দ দাস okay no I have to see if he's around yes you are going to hear yeah. So your question was of course India has planned to send a space station toward orbit. What features of the ISS will be followed in case of Indian space?
They're not
What
here.
will be the question?
So his question is that we are going to launch our space station. What are the lessons that we would like to keep from ISS, and what are the changes that we would like to do? So I think ISS is a 90% piece of machinery which we have been able to put as humanity in this space. It is just incredible to understand that for almost 25 years, more than 25 years now, there have been some humans who have been in space, conducting science, research, everything, in a place where life should not even exist. The most important lesson I think that we need to learn from ISS is technically the modularity, the construction, how it was made possible. Such a big structure we have now, almost the size of a football field. It was done one at a time, like a Lego in space. I think that is the biggest lesson that we have to capture. And it has been upgraded over the years. Even now things happen on the station. It is possible. So that flexibility we need to build in to absorb whatever comes in the future. So for me, technically, that is the biggest lesson. But more on the socially side, I would say the power of collaboration. That stands up. 15 countries, 5 different space agencies have come together to make the space station, and now several more countries have been a part of it, including us by being a part of this mission. So I think that is also very powerful. When you look at something that is made of us. The thing that we would like to better or change is the internal layout. If you look inside the space station, there are wires everywhere, there are equipment everywhere. So yes, in terms of modularity, it has been able to capture how whatever technology future brings, but it has not really been planned that way. So the planning for any stations that we do should be able to absorb this, the future things that are going to come. So whatever is available, cutting edge technology that is available, provision should be made for us to enable that. Even if we can't do it today, in future we should be having provision to enable that. That is what I would say. Thank you.
Jihan Korunjai, Islam.
Sundin sir.
Otherwise, there are questions already. We have to write it down and then.
I did, but he answered in the slides. Can I ask him something based on what you
He has
discussed?
already answered in slides. So you got your answer.
No, it's based on something you discussed. You asked the questions before we presented. Can I ask him please?
Okay, go ahead.
Thank you.
One time exception.
Thank you. So thank you so much, Dr. Shukla, for going to space and for coming to our city. I want to ask you about the scientific experiments that you did on Axiom 4, like the diabetes one. Can you please tell us more about that?
First of all, compliments to you on being so persistent. Getting your question through even when it was not anything like that you'll be able to ask. I was a part of the experiment. Axiom Space is looking, they are partnering with Fuji Holdings in Dubai to enable diabetic patients to travel to space. And the biggest challenge is it is not predictable. If suddenly your blood sugar levels drop, performance, what kind of intervention is needed. So I think continuous monitoring is something that we are trying to look at. How do you get the data in advance so that you can improve it in time? That is what is happening. So I was a part of this in terms of the control, as a part of this experiment. It will take some time, but I can say that the devices that are being used are giving very positive results in terms of continuous monitoring. So it looks like that we will be able to do it, but it is too early to say because the data is still being done. Thank you.
Thank you, sir. Thank you, sir.
Very well. Looking forward. Where is the mic? Where is the handset? Please go ahead.
I have two questions. Number one being, it's pretty simple. Does it seem like if you set a rubber band in space, like when you're in your shuttle, will the rubber band stay in its deformed state or will it regain its original state?
I'll repeat this. So he's asking that if we stretch a rubber band in space, will it retain the stretched state or will it come back to original state? So my question to you is, what do you think is the force acting on the rubber band when we stretch it?
It's the force we are applying on it.
So when we apply, what is it a natural state?
Storing force, but that's my question.
Yes.
This is there. When we are in
It's a property of the material, right? It is not dependent on the external environment. So whether it is on Earth or it is in space, it will come back to its original state. Because that is a property of the material. It is not the force.
not gravity.
It is not because of
It's
gravity.
not gravity.
Yes.
Second question which I had asked was,
Hello?
okay. The second question I had asked was, what is the difference between controlling a plane and a shuttle when you're in space?
Yeah. Magnitude difference, I would say. Maximum I ever flew in planes was around 2,000 kilometers per hour. And here you're traveling at 28,500 kilometers per hour. Also, it's completely different. Actually, it is just very simplistic for me to say this because airplanes work on aerodynamics, and that is the primary force governing everything that you flying, going up and down. And capsules work on principles of orbital mechanics, which is maneuvering in space. So conceptually it is different. And you also do not control the capsules like you control the planes. If you are flying actively in the planes, you don't have to do that in the capsules. Most of it is automated. You have to be ready for intervention in case something goes wrong. So it's a very different type of controlling, but basic philosophy of understanding the machine and interacting with the machine remains same. Thank you.
Okay. Thank you. Dr. Shyamul Mondal, Maharaja Mandil Chandra College.
Shyamul Mandal.
Thank you for coming here and inspiring us. My question was, partly you have answered already that what type of experiment you did in the space stations, and can you also share some results, or are those results shareable or not?
Results are not shareable because they have to be published right now. But I can say that they showed really encouraging results of what we wanted to achieve. And I did 7 experiments. All of them were curated with a philosophy that we also want to do long duration missions in the future. And India wants to do long duration missions. So some of them, like I told about myogenesis, which are looking at the problems of muscle atrophy. Then we also looked at how to solve problem of nutrition in long duration missions, where we can sign up that we are doing macro in space. And so these are the kind of experiments that we did. But the results will take some time for to be published. Yeah.
Okay. Small question from my point. If you ever have in mind that you do an spacewalk using from your keyboard, that the Japanese system will not be just there was a code data was. If you ever feel that you should data was.
No, actually, the coding keyboard is not for spacewalk. It is.
What do you walk around and
No, no, no. The code in keyboard is only for accessing the external facility for experiments. So basically, you open the airlock, you place experiments, you close it, it slides down, and then there is a robotic manipulated deposit. So that is not used for spacewalk, but your question is correct. Yeah. So, of course, that is the next step. I hope we get a chance to do that.
why didn't you try?
Try to get out.
Do spacewalk. I mean,
Spacewalk requires additional I think if I'm not wrong, 2 years of training. Yes, additional 2 years of training to be able to do spacewalk. So I will have to train for 2 years first year, and then I will be allowed to go and do this program. If I would have done a spacewalk in my mission without being approved, one thing I was very confident. I would have been very confident. It would have been my last mission. To do it.
Yes. If they are not following rules and in a traffic police install space to rules like you. But at least it was one trying. But in other words, within your menu,
It was not.
It was not in the
It was
menu.
not in the.
Okay. So next is Dr. Subhanshu Ganguly, Department of English. I'm sorry. I will come back if I have time. But I want to have some students. Okay. GPS. Yeah. Really from students, not from teachers right now. Mostly doctors, they already know most of the stuff.
Yes. My question to you was, in your opinion, how do you see the future of private space startups in India, and how do you think the private industry will play into the space future of India?
I think the future is really bright as far as the private ecosystem is concerned. I touched upon it during my talk as well. That I think some 5 to 7 years back, we had startups in India in the space sector in double digits. Today we have more than 300 startups, and very soon we are going to have the first private sector launch, rocket launch from India. So it is growing at a very rapid rate. And as I was mentioning, that it is expected that we will grow to $1.8 trillion by 2035, the global economy. And I think India will contribute to a very big share of this, going to the private sector growing so rapidly in our country. Thank you.
Next is Mr. Rahul Gorai from University of Poland. Yeah.
So, he is not here, but I am his friend. Both are from University of Poland.
Okay. So,
So we asked 2 questions. I'm sure you're from same university. Do you have same questions?
No, actually, I wrote both of our questions. He said that he doesn't have any questions to ask, so I said he will
you said a lot of things.
So which one do you want? First or
Said
second?
it talking.
First or second?
Actually, I want all of the answers, but
There are 2 questions. One is about perspective, and the second one is about anything surprising in space.
okay, then I want to ask ask you about the perspective.
Perspective. What is one perspective about humanity that only space travel could have taught you? Uh, like I said, I talked about overview effect. It is a documented phenomenon. It happens, and it is very perceptible. You cannot miss it. It is not something that you have to force. It is a very unique perspective that you get when you travel outside the planet. When you leave the planet and you look at Earth from the outside. And so for me, that was this oneness. You know, that planet is your home. Not a particular place or not a particular country or a particular city, but the entire planet is your home. So that really was very, very strong. Thank you.
Thank you. Aditya Chatterjee, class 6, Sri Chaitanya Techno School.
Sir, I had a question. Miss, which upcoming mission are you most excited about and why?
The next upcoming mission is Mission Gaganyaan, wherein we'll be able to send an Indian to space and bring them back safely. So that is the one that we are actively currently working on right now. I'm very excited about it because once we do that, that will open the doors for the next missions to follow, which is like having our own space station and eventually will do. So I think this is a very important mission for us. I'm very excited about it.
And sir, my second question was, what is planetary slingshot and how does it work?
Planetary slingshot. You want to understand that? Here. Yes. Just quickly, I will just every planet is heavy. They have gravity, right? So gravity, what does it does? It pulls you, right? So if you go towards something, it will pull you. What will happen to your speed? It will increase. So if you are going at an angle, you can use this attraction to increase your speed and then go on the other side at a faster speed. That is a slingshot. Like how we use a slingshot, right?
Now, do you know Kepler's law? Okay, Kepler's law says that if you are very close to the planet, your area of theorem is there. So you have to have same equal area in equal times. If you are very close, you have to be very fast because your area has to be constant. That is how we use. And many times the Voyager has actually used this to walk a 20 kilometers per second, then it goes down, again here Neptune, another time, so it keeps going from Jupiter, Neptune to Jupiter by slingshot process. Right now the average speed is 6 kilometers. Okay, next person. Is there a good portrait?
It's a good point.
Let us
Very nice.
Okay. Thank you. Next person is Overseas Sahar, Sri Krishna College. Overseas Sahar, is he there? Next person is Samriddhi Haldar from DAV Model School. Where are these people? Are they from other schools? No, they are not in this room. But you are from the team. Please go ahead.
I want to become an astronaut, but how can I convince my parents?
Are you hearing this all? Please stand up. Our parents should stand up first. Why do you need convincing if you want to be an astronaut?
As a mother, I feel very insecure sending my kid high up here. When they were showing the footages, I was thinking about a mother's psychology.
Yeah.
So how can I create my mind.
I will give you your mother the number of my mother. She will convince you. She will have to no, you don't have, but it's a great question and it is a great point. All the parents who are sitting here. I think, kids have nights of fantasy, they have dreams. Most of the times, we are the ones who respect them. We tell them, you can be only this much or you can be only that much. I'm not saying anything, I know out of concern, but I think education is required on both sides, not just for the child, but for the parent as well. Let them do. They are exceptionally brilliant. They will do things. They will do such incredible things that we can't even dream of. You go, you be what you want to be, and if your mother stops you, don't tell her. That's what I did. I didn't tell my mother that I'm applying to be an astronaut. You also do the same. Okay?
I want to make one more interesting statement. In India, 15% of the pilots are females, whereas in the entire world, only 6% pilots are females. So India has more chance of females to go to space at least 2.5 times. So she does not inform she. You will become. Just stick to your gun. No, I will become. You have more chance than any other country. The Valentina Tereshkova, when she went, she was a gardener or something. No profession, professionally not at all education. But you say no, Russia has it. Today you see the average. Average. India has more pilots to all you must be knowing. You saw the during the operations in so many pilots in the Air Force. You have chance. I guarantee you. Okay? Now we take things. Thank you.
Doesn't work for country.
Yes. Now, Sodasi Shaha. See around? Maybe in some other. Let us try. Let us keep it out of it. There, we need to know that. Rajoshi Rai from Bethune College.
Okay, very good to meet you. It is Rajoshi Rai, I think. Dr. Rajoshi.
Rajoshi.
Yeah. The thing that I have asked for is that the psychological aspect means you are very different from others. That is why, though you have the same food, though you have the same clothes, but psychologically, the self-motivation and the psychological orientation of yours is quite different. So, what are the things that you feel that should be a special possession of the astronaut so far as psychological qualities or mental abilities is concerned? And also, one or two lines of your feelings, as you had mentioned, how your mind was feeling when you were in the space.
I think psychological, mental state is really important for you to do something like this. These are difficult missions. They require a lot of sacrifices. So life becomes different when you get into such professions. Even as a fighter pilot, and even after that, even more so when you are training to be an astronaut and when you go for missions. So it does require a different type of way of approaching or thinking about things. And one thing that is very important is the resilience that you need to have. Come what may, you need to have a very strong belief in yourself that whatever it is, we will make it happen. We will do it. Whatever it is, it doesn't matter. So I think that is what I feel my strength is. I have always thought that at a very young age, this thought came to my mind when I was doing my training in India, and I'm just 17 years old that time. But ever since then, I've carried this. I have felt this very strongly that if there is something that a person next to me or anybody on this planet can do it, then I can also do it. It is not something very different. We are same. We are similar build and everything is same. So if somebody can do it, then I can also do it. And I think that has allowed me to pursue things and go on and move on with things, even when they were challenging or when they were difficult. And when you are in space, there is a lot of things. There is a psychological shift that happens. But most of the time, you are really busy. you are doing a lot of work when you are in space. When you get a few moments, then that is the time you look back and you realize of what is happening, how are things changing, and how just the enormity of what is happening. So I don't think that I have really sat down and thought about it till now. I have not had time, but there have been a few moments where it hit me that what is happening is something really big, and this is very exciting for me to be able to do that. So I would say just that. That is what allows me to carry on and go on. Thank you.
Deepika Das, BBA International. Please come forward.
So I have the question. If there is something about comfort, what would you say about it in the space station?
I will read her question. She is not being honest. She is written, growth happens outside the comfort zone. How much out of comfort zone were you in the space station? And then the last line she writes, also please a photo and an autograph. Thank you for your question. I think being uncomfortable is something, there is a very common culture that is said in this astronaut community is that you have to be comfortable in being uncomfortable. That is what the nature of job is. So you keep doing these things over and over again, whatever is uncomfortable, and then you become used to it and you become okay with it. Being uncertainty is a part of life. Getting in the space suit, sitting in that position is not comfortable. It is uncomfortable. So you have to push yourself and you have to be in that zone because that is exactly where growth happens. When you don't feel like doing things and you still go ahead and do them, that is the time when change happens. So that is also for you and for everybody else, all the kids who are sitting in. Push yourself when you can, as much as you can, because that is when you'll see the magic. Okay? Thank you.
नीलर का पहाड़ी पाथफाइंडर हायर सेकेंडरी पब्लिक स्कूल no access center because you need to and you open a target no we have program okay नीलर का पहाड़ी
So my question was, what is the future direction of ISRO space missions? And this direction ISRO trying to go in order to make India more prosperous. So what would be your role in it?
I think I've spoken about this. We already have laid down a policy where we want to go. We are doing scientific missions as well. And in terms of human space missions, we have missions that I've talked about. So we have a clear plan. At least 15 years from now, we already know which direction we are going. And I do have a role to play. Whatever experience has been gained has to be used by the system to develop our own systems and machines and equipment that we are going to set up. So that is what I'm working on currently. And these are the possibilities for you in the future. So when you grow up and you're out in the field to join one of these missions and be a part of it. Okay? Thank you.
One follow-up question I want to ask that Rakesh, when he came back, India wasn't prepared to utilize his space technology. Now you have used the most sophisticated instrument which has been created for the last 26 years, 27 years. For 25 years, it is inhabited. Now, after coming back to India, when you find that the Indian situation, it is growing, but will you say that your expertise can be utilized by Indian space program fully, and if not, from when you think that you will get the same environment, same quality, and you space. Point I'm trying to make is that Rakesh ji actually was not used. I mean, his expertise that time because of we didn't have PSLV as I said. And even today, we did not send anybody on our own. So myself, I feel that Rakesh ji's expertise or the whatever experience he had did not be utilized. Probably he became trusted because they're a human being. That is possible. Do you see that in foreseeable future or even next 20 years, if some space program is not, like space station is not will be, or your expertise will not be utilized, that you do not go even because we have not been able to bring any instrument back. So far, the docking and unlocking is not really completely mastered. We did not land anything on moon, which came back again. So there are certain steps have to be done before anybody, like that lady and this little child, would anybody saying his or her kid up there when India has not done all these steps. So do you think that your expertise will be utilized fully within your lifetime, say another 60 years?
The situation is different when Rakesh Sharma arrived on. We did not have a university, as you said. The situation is very different when this time I have gone. I have gone to space for a reason, because we are doing the development mission. So it is a stepping stone to our mission. That mission is not done in isolation. Having said that, already there are mechanisms in place because of which my experience is being utilized, and I am contributing and talking to the teams, design teams, sitting down with them, figuring out how to enable this for the future. So it will happen. All these steps that you're saying, they will happen. Now, but just to quote what you said, if in 20 years of time we are not able to launch a space station or a Gaganyaan mission or do something, then I think I would have failed, not the system. Because system is geared up to absorb with experience. And we have to make it happen. And I'm confident that we are working in the right direction and right way moving forward. And everybody is aligning and everybody wants to make it happen. So the situation is very different as compared to the last time. And so I think it is a huge responsibility that they have, that we need to make it happen. And the concern that the mob here had, it should not be there. That is the kind of confidence we should be able to build in people when we eventually get there. And it is as safe as traveling in the day. That is what the aim is, and I think that we will achieve that as well.
Thank you very much. Sir, my question is Somrita Ganguli. How does it feel to return? Okay, yes,
Good afternoon, Captain Shukla from a fellow JNU alum. The first question for our team to one is, you talked to us about the physical rehabilitation process that you had to go through after coming back. My question is about the mental rewiring. How do you return to the daily business of life once you touch the cosmic dimension? How do you deal with traffic and Uber cancellations and Amazon deliveries? How do you go back to daily living?
I don't think you have a lot of options. You have to go back to daily living. That is how life takes over, and it has been very different after coming back from the mission. But the daily life really takes over, and I think there is a shift that happens in how you see things. But you cannot start comparing everything that is happening with you with what you experience, and it will be very different. So you do what you are doing on a daily basis. And, you just go on with life, I think. So yes, there is a shift in how you see things on a larger scale, even about life, how it is going. But every day, like the frustration that you have when your Uber gets cancelled, I also get the same frustration. So I don't think that changes a lot. And it is similar. It is not a lot different. Thank you.
Love your body. Love your body, your horizons.
Sir, actually the question I wrote, you already answered that.
So I want to ask another question. That like you went to like the gravity you told that you showed us the video like how you felt after 2 hours coming. Like how much time did it take to like reset to the ground conditions?
For me, it took about 7 to 8 days for me to be reset to normal conditions. But there are some long-lasting changes in terms of your, the muscle loss that you have, the physical deconditioning that happens. Those take time. With training, they come back over a period of time. But your normal day-to-day functioning, for me, it took about 7 to 8 days. Thank you.
Developed from RKM, Islamudi Northern, Ramakrishna Mission, Islamudi Northern.
So, I would request you to enlighten us about what is the how much concerning it is to think about habitation in Mars or any other planet or place, extraterrestrial places. As we should think about developing our world to for our long-term rehabilitation.
So I think we have spoken about this a bit of the challenges of going to Mars and settling.
What should be our main concern?
Yes, yes. So the challenges are, a lot of challenges have to be handled before we even get there. So habitation is something else, but even before we get there are a lot of challenges that we have to overcome. And even on Mars, when you get there, you have to be able to live. Life, as you know, has evolved in the conditions of Earth. Oxygen is required for us to live. All our processes are evolved in the environment of gravity. And when you get there, it is one third of this environment. The atmosphere is different. How do you enable on that? So these are the problems that we need to address before we even get there and start talking about these issues. So I think it is the long road. But the second part of the question was, what we should look at?
What should be our main concern? We may try to make our world more developed. We may develop our world more so that we can live here.
Yeah, so I understood. We are not like, I think this was said by Professor also in one of his statements that he said, we should not be going to Mars because Earth is not livable. We should be going to Mars because we want to go there, and we should definitely preserve what we have because this is all the life that is existing here. So there should definitely be an attempt to preserve this. We should go there out of curiosity, out of the necessity to find out more, or develop systems or technological advancement that we want to make, but not out of necessity to live. That should not be the reason. Thank you.
Just one small addition. That when the earth was created, there was no oxygen. So the cyanobacteria took 1 million years to produce oxygen. Algae, you take some algae, traveler, they do photosynthesis. Immediately they produce oxygen, methyl became methyl alcohol and methanol and all this. So huge done. They keep on making it. After 102 years, we got this terraformation. It is called terraformation or bioformation. Biosphere was where biological stuff. Okay. So Mars is not the problem fundamentally Mars. Magnetic field is missing. If the magnetic field is missing, then the atmosphere will be disturbed, will go away immediately. The water will go away immediately. That's what happened. Mars already had life 3.7 billion years ago. So it is not that you want to just do it, but first you have to keep the magnetic field so that the Earth, so the sun's radiation does not ablate but evaporate the Mars atmosphere. That is both recharge cyanobacteria. So they will keep on making oxygen and sun's radiation will keep on evaporating. Bengali they say, एक ही बोल तीनों रात से जल डाली तो बात इटा चेष्टा So unless you have magnetic mass, there could be something water underneath. You can do 5 10 50 20 50, but not like a block. That's not the question of oxygen. If you start making it, there will be help for it. No, yes, they will escape. First of all, it is small object. Its velocity is smaller. Its velocity is very small. Then you keep on making it, and then you will get it. You have that magnetic field loss. 3.9 billion years ago, magnetic field was lost. Thank you very much. Lopamudra. Any chances to send any female astronaut from India? Lopamudra is.
Any chances to send any female astronaut to India? Yes. Yes, there are chances. Absolutely, it is.
More than many other countries.
Would you apply? Would you be there? You want to go? Enough, right? There will be chances. If you look at the first few missions, the first missions are prototype missions, and they restricted it to just direct selection for the participants. When we have probe marks twice, we have proven the machine. If you open up to all the disciplines, all the domains, and everybody will get to. Only thing is you have to eat well, you have to play sports, be fit, and you have to be mentally very strong. Develop these skills, and you will be in the right position to apply and become one of the experts. Okay, thank you.
Not everybody has to become a pilot. You can be a school teacher, a cinematographer. That we have the challenger disaster. Unfortunately, the past class teacher. You end up with disaster in that. But this was an ordinary person, a class teacher. So look, people can, you don't have to fight. You don't have to, pilot Rafael situation. Now the next question is Capt energy. Is Capt energy of this one? Lopamudra. So Capt energy.
So polar energy is not here, but I can spread. So
Okay, you have to say the same question.
yeah. If you can ask, you can answer the question.
What is it?
Okay, so the question. What is your name?
My name is Pracheta from Ashomar, and my colleague was also from Ashomar.
So the question is.
You are Pracheta from Ashomar.
Yes.
But you are a newspaper item. Newspaper person cannot ask directly question. That is the rule. So the question is what you ask.
The question was
Are you from media?
Yeah. Yes, sir.
That is that.
Are you going to print this? This is just for curiosity.
That is
Just for curiosity. Okay, so this is not for.
No. We will assume that the Capt energy.
I think this is an open platform.
Yeah. So I'll answer this.
Thank you so much.
But it is just because you want to know this, right?
Yeah, sure.
So the question is, the Gaganyaan mission is scheduled to take place soon. Has the training started? If yes, then what type of training it is? So we were selected for Gaganyaan mission in 2019. We've been training ever since. Training started in 2022. It takes a long time for the astronaut training to finish. On an average, 4.5 years before you can fly on your first mission. And then you build on experience, and then you fly as a commander on the subsequent mission. So it takes a long time. So we have been training, but it is not a conventional mission. You are not just going to go for a mission. Our job is to evolve this mission to make it happen. It is the first mission that we are doing. It's a prototype mission. So we are working together with the teams. We are also training, and we are also helping evolve the systems. Whatever is going to go up and so on. So that is the work that is happening right now. Thank you so much.
Thank you. Last question. Shobha Kumari. You? Okay. Absolutely last question of the day.
Difficult part for you while
Yeah. But I would answer the third question again, not the second question. The third question that he has written is what type of difficulties a female can face to become an astronaut. I don't think when you wear a spacesuit, it looks at you as a male or female. You are an astronaut. So the challenges are safe, the difficulties are safe. No, it is a challenging job. It is a difficult task to do, and most of all, you have to be committed. We are all excited as a country right now because this mission has happened. This was a 20-day mission. I was in space for 20 days, but I have been selected in 2019. From 2019 to 2025, 6 years. All of this was work which was not known to anybody. So it is the mundane that you should be ready to do to get to the excitement. I think that is what is important, and that is what you should say back. If you are ready to put in the work, if you are ready to, just do the work every day, even when you don't know whether it's going to work out or not, I think that is what is required for you to be this. Thank you.
Small post-tree, females have less amount of muscle and their size is smaller, lighter, their muscle decay is generally affects. Biological problem. So if you stay the same number of days in the male, males are generally well built, so they decay. So they decay at the same rate, but they that is the only problem. If you don't stay for longer time, then it's fine. Very long time, then it's a problem. Okay, but your okay, I'm sorry. The program is over. You are most welcome to have tea and biscuits. Please don't come. No, nobody comes here. Out of the time is really out. Now, I'm sorry, both of thanks and then we
I extend my heartfelt thanks to all of you for joining to us. It is a moment of immense pride to welcome Shukla, the first international to visit the International Space Station. Sir, your knowledge and your inspiring experiences have enriched us and ignited the space and love. We are truly grateful to you for honoring